Welcome to the Rethink Vertical podcast, where we cut through the hype. This podcast brings you emerging aviation technology insight without the fluff, so you know where the industry is today to shape the future of tomorrow. Welcome to the Rethink Vertical podcast. This episode is sponsored by the UAS Cluster Initiative. So today I sit down with co-founders of ResilienX, Ryan Pleskach and Andrew Carter. ResilienX is the market leader for in-time aviation safety management system software. Their safety assurance solution framework monitors the health, integrity, and performance of the systems involved in advanced UAS operations. The software also provides the monitoring and maintenance backbone of op centers throughout the UAS industry. If after our conversation you want to learn more about ResilienX, you can check them out at www.resilienx.com. That's ResilienX.com. Hope you enjoy the episode. All right, Ryan, Andrew, welcome to the podcast. Really looking forward to this conversation. And so with that, we'll go ahead and get started here. I'll start with you, Andrew. I think it's ResilienX is a company that we've been following for a long time. It's exciting technology that you guys have. And so just for the folks listening, I wanted to give you guys an opportunity to share a little bit about your history, how you got started, how you started building this company. So Andrew, take it away.
Absolutely. Yeah, so back in about the 2017, 2018 timeframe, we were coming off of doing the Army ground-based detect and avoid system, which was certified by the FAA for routine beyond visual line of sight operations back in 2016. And we started looking at opportunities in the commercial space. And the company I was at spun off a wholly owned subsidiary to go after commercial work. We were a defense contractor at the time. And so we started getting really involved in UAS traffic management, or UTM. So back in that time frame, I was actually doing the systems engineering leads on the New York UAS corridor and the Ohio Department of Transportation system, or UTM system. And what we found is that the ecosystem back then was extremely brittle. We had all of these different companies that were, coming together and putting their solutions together and, trying to duct taping them, gluing them, and trying to get some demo to work. And what we found is that we would, spend all of this time trying to get the demo to go, and then something would actually work correctly. One time it was like, all right, pop the champagne, put out the press release, and then tear everything down and go home. And that left us a little perplexed, because we were like, well, we can't operationalize or commercialize this industry if this system of systems isn't bulletproof. The FAA had really just pounded into our heads for the last 10 years on the Army system that you needed to have fault tolerance, you needed to have graceful degradation, you needed to have health and integrity and performance monitoring. The system needed to be fail operational. It needed to run at all points in times. And no matter really what happened, unless it's some cataclysmic event, you needed to always maintain some bar of safety. And so that was a little bit easier when you owned all the pieces like the Army does. And so we started looking at how this system of systems ecosystem that was being built up for commercial aviation or commercial uncrewed aviation was forming. We realized there was kind of a gap there. We really just didn't see any way to dictate fault management schemes and requirements and other pieces like that to all of the individual players. And really, to us, it screamed, well, we need some kind of system that does this. And so ResilienX was really born out of the idea that we could take all of our lessons learned from that Army system. We actually brought on the team that built that system and figure out, okay, can we productize that knowledge base into a product that can do that for the drone industry? And 2019, ResilienX was formed.
Yeah, no, I think it's always valuable to hear how the company got started and what problem you guys were trying to solve. So Ryan, I know of a couple of projects you guys have been working on, lots of exciting things going on. Are there a few projects that maybe you want to highlight for the folks listening?
Yeah, I think I'll dive in. I want to add on to what Carter said, though. A little bit of a funny founder story, right? So he initially approached me about joining him in this adventure, and we went to lunch at this burger place right next to the tech garden where we're based. And he's like, I will handle all of the technology, but I need someone to handle everything else. And at the time, my background was largely in program management, project management, and I'm thinking, a startup. In a maturing industry, right? Is there going to be enough for me to do on like a business or a PM basis? And so we joke about that now every night at 9:30 or 10 o'clock when we're exchanging Slack messages. Right.
How bored you are right now.
Yeah. So to get back to your original question, yeah, we've got a couple of projects that we think are really, really crucial to advance in this industry. The first one that I want to highlight is we call it WSDM, WSDM, which stands for Weather Sensor Data Monitoring. And what we've done there is we've partnered with True Weather Solutions, another great company in this industry, and their premise is that humans have only cared about weather really above like 1,000 feet. No one's ever cared what the wind is doing at about 30 feet off the ground. And so what we did is we partnered with them on a NASA Civer to look at how can we blanket an urban environment with low-cost sensors and try to fill in that reliability and the trust gap for urban weather, urban wind data. So we targeted Hampton, Virginia, where we've deployed, I think we're up to about 18 weather sensors now. Some are low cost, cheap weather sensors, more attritable, and some are higher cost, like, $8,000 a piece. With the whole theory that do we need 30 or 300 of these $8,000 sensors across every city? Or can we maybe place a couple of those really expensive ones and then fill out the coverage area with more low cost sensors? And if they stop working or if they break, we can essentially throw them away, and it doesn't prevent what we're still trying to do in the area, which is gather sensor data, gather intelligence, and decide if the wind is going to be too much for a craft to fly in. I'll give Don a little weather pitch here, right? His claim is that 30% of drone flights are canceled, or up to 30% of drone flights can be recovered because of they cancel because of unknown weather conditions. And True Weather can reclaim a significant chunk of that and help make the drone case more economically viable. That's for so Carter, you want to add?
Yeah, I was just saying, in that program, the piece that we're really bringing to that, right? I think that Ryan hit on the vision. Again, going back to the technology piece, that's my wheelhouse. Really what we're doing is we're actually using our resilience framework platform, which is actually our product, stands for Fault Recovery and Isolation Health Monitoring Framework. And what that's doing is monitoring the health and performance of these cheap, $400 or $500 weather sensors to make sure they're actually giving good data to the ecosystem. What we don't want is for, a $500 sensor to start pumping out bad data or to freeze up or to fail, and that data getting propagated into the weather model and then causing bad decisions downstream. So our software is really acting as this digital infrastructure layer on top of that network of weather sensors to be able to determine if they're all working correctly, and then almost as a gatekeeper that data can then be used for weather prediction, weather forecasting, and the current now weather.
Yeah, no, I think that's an important point. I think a lot of when I talk to folks about technology and technology stacks, and they're like, oh, we got this piece of tech that's really cool, and we want to we want it to be available for use in some type of certified system, right? So I think a lot of times, I know we've talked about this, folks forget that the reliability of the data is even more important than the actual technology behind the data, right? So if you're talking about a system that's using multiple data sources and you want to be able to use this in a safety type system, it's great if the data if it's cool data, but if you can't rely on it, you don't know when it goes down, what's wrong with it, then it's just a cool toy, right? So I think what you guys are talking about with the work with True Weather, it's important work. I mean, knowing if you're getting data that's good data and how to, carve out pieces of data that aren't good and not shut and reset the whole system. It's just such a valuable thing.
Yeah, so that's a great segue to the second project we wanted to highlight today. Last year, we spent most of the year working with One Sky Systems in Australia, helping them build a prototype FIM system. We were one of 2 or 3 teams that were selected to kind of bring together an approach for Air Services Australia to evaluate, and we're expecting them to pick a winner any day now. But what we did down there is we provided our framework software, and we have a service we call the Data Integrity Service. And the demo we did with One Sky was essentially there was the blue tunnel on the map, which was the conformance volume. And there was a drone, simulated drone flying through the conformance volume. But really, that drone it can float in and out of the volume as long as it comes back in once every 30 seconds or so. But realistically, you don't have a very good idea of a precise location or where that drone is. So if that drone could start bouncing around erratically inside its conformance volume, an operator or a system maintainer is not going to get an alert that something is potentially wrong with the craft. Or maybe it's the radar, maybe it's the data that you're getting from the radar that's bad, right? So what we do is we monitor the data, ensure that things like the craft isn't violating the laws of physics. At a simplistic view, we have much more advanced algorithms running behind the scenes.
Right.
But if the drone is at point A at one time, and then it's at point B, which is 2 miles away, and it traverses 2 miles in like 12 seconds, well, that drone probably isn't flying, several hundred miles per hour. So I think we brought value to that project there. And one Sky, we've developed a good working relationship with those guys for the Australia effort, and we're excited about the kinds of things that our product can bring in various market segments within the UAS industry.
Yeah, to piggyback on that, I think that you'll start to see a lot of value as you start to get to one-to-many. Right now in traditional air traffic control, there's a human being watching every single track and dot on that screen.
Right.
And if one of them starts to do something funny, right, immediately on the phone, calling somebody, what's going on, what's happening, what's the deal? You start talking about thousands of drones over, a single city, or, an operator having to monitor, 20 plus operations. And you really do need these, automated software agents that are actually monitoring the data feeds. And even if they're not necessarily doing something, alerting the operator, you need to address this issue, you need to manage this contingency, so that you can have a single, you allow the system to scale that way, right? The more kind of automation you can put into place and the more trust you can build, you can allow that scalability factor.
Yeah, it's an interesting point. It takes me back to my air traffic days, and you talk about, there are systems set up to alert you of issues, right? Whether it's ADS-B or just loss of radar. So it's a multi-tiered safety system, right? You've got the system telling you, recognizing an error, and then you have a person seeing that warning and reacting to it. And so you're going to need, my opinion, from the FAA perspective, you're going to need to try to recreate that as best as possible, because that's the system that they're currently comfortable with, right? So to say that you're going to have hundreds or thousands of drones operating and, verifying the reliability of those vehicles are operating safely and the way they're supposed to, and then a system that can monitor it, and then having some type of other system that can react to when something goes wrong and how you fix it, right? It's all that tiered process. So, I think that's why what you guys are doing is so great. Any other projects that before we move on?
Yeah, I think the final thing we'd like to highlight today is, this is actually kind of more breaking news for you in your podcast. We have recently signed an agreement with the ResilienX group out of North Carolina. And this highlights kind of the experience that Carter was talking about earlier, where we're providing more of a systems engineering support, but we've been put on contract now to do system design for the ResilienX Atlas system, which stands for Air Traffic Low Altitude Surveillance. And really what it is over the next few months, we're going to be working with them to really do all the behind the scenes, or all the upfront work, I should say, for the design of what their eventual UTM system is going to look like. ConOps, use cases, requirements, and ultimately providing our software framework as a part of that overall solution, which we're hoping will be kind of up and running August, September timeframe this year.
Oh, wow. That's also so how do you guys go from system monitoring to system designs? Is that just sort of, I've talked to other founders and other companies within this industry, and it's almost like they do this work, they develop this technology, and then they say, we've also got to do this thing in order to help, kind of catalyze what we're doing. Is this a similar sort of situation?
That's almost exactly it.
Okay.
It was one of these things where we know we wanted to have our software in place in that system, but it was what are all the things that have to happen before they're ready for our software?
Right.
And it was one of these things that it kind of came together, and we were like, well, we think we can help with that portion of it. We think we have the bandwidth to get it done. Luckily, there's been a lot of times in our business we haven't had any extra bandwidth, but we had a systems engineer break free that we were like, yeah, we can work this and get this together. And so So yeah, we're pretty excited about that. I think that you're going to start to see these systems in urban environments, which I'm super excited about, just to to start making progress on that. Those really exciting use cases. Medical delivery is a big one here. Public safety, drones as first responders, kind of some great use cases that obviously are largely going to be in urban environments, or at least over people.
Yeah, I think it makes sense because you guys understand the problem too, right? So you understand what they're trying to do, and it's like, we should probably help out with the designing this, the system design, since we're the ones that really spend all of our time thinking about this.
Right.
So glad they brought you guys on for that project. All right, so we've talked about some projects. We've talked about how you guys got started. I'm always curious for this type of technology. We had Aaron Pierce on from Pierce Aerospace a little while back, and I asked him this question, because when you start talking about remote ID, most people are like, what is this thing even? And so we're talking about system monitoring. We've kind of touched on it a little bit, but for those folks that maybe aren't just living in this industry all the time, why is your technology important? Why should people care? Right? It's not a drone. It's not this thing that they can physically see.
Sure.
What is so important, and why is it needed in order for this industry to scale?
Yeah. So in the last 6 to 18 months, depending on which geographic part of the world you're looking at, we're seeing regulation and regulatory bodies are really coming down and guiding the industry towards certain answers, where we think the final regulations are ultimately going to end up. And I can read just two of them real quick, and this is much more Carter's bailiwick. So I'll provide the guidance that we're seeing and let Carter expand. So from EASA, which came out really at the end of 2022, the applicant has a means to monitor externally provided services which affect flight critical systems and take appropriate actions if real-time performance could lead to the loss of the operation. So that's talking specifically about acceptable means of compliance or meeting a whole bunch of EASA and EU regulations around, complex drone operations. And then I think it was at the end of 2021 or in the fall of 21, the FAA came out, so actually first, with a similar set of standards, or I should say guidance documents. They had a memo that they call Associated Elements for drone operations. Mm-hmm. The Associated Elements require in-service monitoring to detect out-of-compliance performance and initiate corrective action. So both of those in our parlance is saying you need to monitor the systems that are enabling this system of autonomous flight.
Yeah. So requirements. You foresee that this will be a requirement to operate in the system, right? It's a good reason.
Yeah,
we view them as requirements already.
Yeah, so I think that you can view it in a couple of ways, right? You can say thou shalt be mandated to do this by your civil aviation authority, and that's obviously a reason. But if you want to dig into why the the CAAs or the FAA or EASA is putting that guidance out or starting to mandate those type of things, really it's around safety as you start to go into automation and autonomy. When you're trying to do highly automated things, it means that you have systems making decisions, which is great. If you can take the human out of the loop, that's really the only way to start automating and to scale things. But when systems are making decisions, they're only making decisions based on the data they have. Right? There's an old adage, garbage in, garbage out. So if you have decision-making, systems, again, whether this is, basic decision trees all the way up to neural networks, right? If it's, systems making a decision and you can't trust the input data, how can you trust the output data? And what you're seeing in a lot of systems is that they always output an answer, right? They don't tell you, I didn't have enough information, or they may not know they didn't have good information, and they're still going to give you an answer. And so when you look at this system of systems, there's a lot of different data being provided by a lot of different sources. It gets very complex very quickly as you start to look at the grand scheme of things. And having a layer that says, we're going to monitor all of that data and be able to tell you when systems are working, when they're not, when data is good, when it's not, when there's not enough data, when there's problems, all of those things so that you can start to trust the data within the system. And then built on top of that, you can trust the decisions that are coming out of your decision-making processes. That's really where our stuff comes in. That's kind of the inside baseball behind the scenes, right? What everybody sees is the output of the requirement from the FAA or from EASA that says, that shall have monitoring of your system. But when you really dig into why is that necessary and kind of think about, well, how does this thing automate? that's really kind of where we get to.
Yeah, no, I think that's a really important point. I think some of the folks read those documents that you talked about, Ryan. They see monitoring, and in their mind they're thinking, okay, we've got someone in this room monitoring the operation. It's like, yeah, that's great for a pilot program where you've got one aircraft operating, but no business will succeed at that level, right? In order to scale, you're going to have you have to be monitoring systems, not with a person, right? Systems have to monitor themselves, and then so I think that's really interesting. The last thing I wanted to chat about is something that I ask everybody, and so 5 years now, Resilience. 5 years ago, started this company. You guys started this company, and I'm curious, what are some things, maybe lessons learned? If I had to do this all over again, this may be a different path you would take. Always curious to hear some feedback on this side.
I'll go first, or
Yeah, sure.
Who wants to take that one? Right.
Yeah, so there's some stuff that's not necessarily what I would do differently, but more just like lessons learned about things that we didn't expect, or maybe kind of turned out differently than we thought, right? So I think one of them is there's everybody told us that we were too early, which frankly was probably true. So I think that was an interesting, just like entrepreneurial thing, right? Is that 4 years ago we were too early, but we were able to build the business over 4 years, and now we're seeing traction all over the place because we have a product ready to go that has some level of maturity. It has some some systems behind it. We have proponents for what we're doing throughout the FAA and NASA and the UAS test sites. We have enterprise commercial customers. And so what was too early 4 years ago, if we were started right now, these groups that need a solution would be looking at our idea going, well, yeah, that's an idea, but where's your solution? So that's just one of those things that I think about sometimes, about when people tell you you're too early for something, it doesn't mean it's not a good time to start it.
That's a good point. Ryan, what you got?
I think for me it would be there's not a lot that I would do over, but I think one of the foundations of what's gotten us to where we are so far is the relationship that Carter and I have, which is he's very much the optimist and I'm very much the pessimist, right? He's like, oh yeah, that contract that's going to come in, and I'm like, well, no, what if it doesn't? And we got to so just having that that give and take, and that making sure that we look at all problems from. We do have analysis paralysis sometimes, right? I will ask Carter the same question 3 days in a row from 14 different angles, but we make sure we arrive collaboratively at the best path forward. We communicate that with our team, and then we set our flag in that direction, and we start marching towards it. And that's really all you can do in an industry that's still mature and with a product that's maturing with the industry, right? So we tell people all the time, right? We are not selling a better widget. We are selling a new widget in a new industry, and that's a challenge that has been both extremely frustrating and extremely rewarding at times.
Okay, yeah, go ahead, Dave.
I'll just extend on that a little bit. I think, to Ryan's point, unbridled optimism it can be problematic. I know I have a problem with it. Since we've started this company, right, we've gone through a pandemic. We've gone through, venture capital that has died, venture capital that has gone crazy, venture capital that has died again. Like this, state budgets that we were, line items in got rewritten because of COVID. Like, you really have to make sure you have, we use the term contingency management with our product, but within the business, we've had to manage a lot of these contingency situations that we didn't expect. So I think if we had been, gung ho, full ahead, yeah, we're gonna do this. We're gonna raise $5 million, then $10 million, and the industry is gonna blow up, and the FAA is gonna give you regulations, right? All of the stuff that hasn't happened. I think having a realism and a realistic approach, and pessimism is maybe looked on negatively, but I think more realist or risk management is certainly something that I think has been really helpful for us.
Yeah. So what I hear is you're both big proponents of the co-founder model. Can you imagine going and trying to do this on your own? it's a heavy lift. So, and I've heard that from many. I know you guys have been through a couple different accelerators, so I'm sure that was some advice that folks provided to you. I've got a couple minutes left here. I just wanted to ask one more thing. So you mentioned investors. I know we have quite a few there that listen to the podcast and other startup founders as well. On the capital raise side, any advice for folks that, like you said, they're too early, but you kind of have to, I mean, from an R&D perspective on some of these technologies, you kind of have to be early. So any advice for folks that are going out and raising money right now? Right. Ryan Smith tells it all, right?
I think the good thing, at least within the industry that we're in, the UAS industry, is that it's starting to move. We've seen a lot of indications of things starting to grow, things starting to scale. Companies, larger companies starting to put money behind the technology because they see, the light at the end of the tunnel. 4 years ago, that wasn't the case. So the story we told 4 years ago was very much more visionary. I think the story that founders can tell now is, look at data points. Here's things starting to happen. Here's, the projections that you're getting from, the Walmarts of the world, or, some of the European countries that are trying to put up new space, right? There's a lot more, I think, data to start to look at and point to, and to show those, those dots starting to connect. Whereas I know when we first started, right, it was very visionary. It's like, we think someone's going to need this eventually.
Right. Yeah.
Yeah. I guess what I would add to that is it's incredibly, I don't know what the right adjective is right now, but our vision 4 years ago and our product 4 years ago, it's actually been very consistent. We haven't pivoted in the sense of, okay, well, we're going to build widget A, and now we're going to build widget B because the market's going to pay for B. We've actually been very consistent with our product framework and what it can do and who we're targeting. We found some, I would say, adjacent markets that we've dabbled in a little bit. We had a U.S. Navy SBIR contract to look at applying, still our core framework technology, but applying it to Navy ships or unmanned ships. And we're still dabbling a little bit in that kind of stuff. But for the most part, we've remained incredibly consistent in who we're targeting and the reasons for targeting that market. How does that tie back to fundraising? I think we have tried various times to raise money. And I think what we found is every time we try to go and we try to raise a priced round, we have some kind of win or some kind of traction that makes us maybe recede back a little bit. And, why take the extra dilution, or why take the dilution of a large priced round if we don't need it? And so I would say that balance has been the hardest part for us when it comes to fundraising, venture capital, and then taking all of that and targeting it to the appropriate investor. We have taken some angel money over the last, I would say, it's a little over a year, I think, since we started fundraising. A little plug for the Genius. So we got our start in the Genius program, Genius New York, the accelerator here in Syracuse, New York. But other than that, we've only taken a little bit of angel money last year, and bootstrap if you can, but you got to be ready to pounce when you need that money. And we're right on that threshold right now of, $500,000 in the bank right now would be amazing, so that we could get a couple of people in-house, get the engineers trained up, get over any onboard and speed bumps before the storm hits. And the storm being all the traction we're expecting on the back half of this year. Right.
More work than you have to do with, right?
Right. So it's a very fine line between staying lean and staying capital efficient, but also having enough resources to do the work that your traction, is going to bring upon you.
Yeah. Those are real valuable words. Thank you for obliging me on that question. It's a really great chat with both of you, Ryan, Andrew. I look forward to seeing how ResilienX continues to grow and have success. And I really appreciate you guys coming on today.
Oh, we appreciate the time. Thanks, Craig.
If you'd like to be a part of the UAS Cluster Initiative community and get access to more of our content, check us out at www.uascluster.com.